Hello everyone, this is my project on instrumentation and drive systems. The topic is about designing of an autonomous vehicle using LabVIEW and Arduino. Here is my diagram for the autonomous car. Hello everyone, this is my schematic diagram for the autonomous car assignment. I will quickly take you through the components which I have used. Servo motor. This motor is considered to control the direction of the car, used as the steering wheel control. Push button, or it is used as a bumper. This push button acts as a crash detecting switch. Whenever there is a collision, this will convey the Arduino to stop the motor control. Ambient light sensor. This sensor has a very useful control over light. When light intensity is low, the headlight of the car will turn on automatically. The chip we have used to control the DC motor is L2930. This is used to control the speed of the DC motor. This motor acts as a rear wheel drive to the car and control the speed in anti-clockwise and clockwise direction. A battery of two 9-volt is connected to the chip to power up the motor. The speed of the motor is set to 612 rpm. There are three Arduinos used in this project. One is master, another one is slave 1, and the next one is slave 2, which are connected to the master. All the components are attached to the master Arduino except the potentiometer, which is connected to the slave 1. In the slave 2 Arduino, this slave 2 Arduino is connected to camera, but there is no camera in the simulator. So we are getting values from this serial monitor ranging from 1 to 3. 1 is easy bend, 2 for medium bend, and 3 for hard bend. After getting input, it transfers the data to master Arduino under some conditions. And servo motor will turn whatever the user inputs through slave 2. The ultrasonic sensors are used to direct the vehicle without any obstacles or hitting the vehicle on the way. The ultrasonic sensors are used to direct the vehicle in the correct path on the road. The three sensors used are placed in the front and each side of the car. This will calculate the distance between the obstacles nearby and provide the information to the Arduino to calculate and drive the car in a safe manner. This is all about the sensors which I have used in this assignment. I will get quickly through the codes which I have used. Initially, I have mapped all the pins which are connected to the Arduinos. In this void setup, we have set up all the initial values to run the problems. In the loop, all the recurring activities will be mapped under. I will just quickly take you through the codings. This is for the master. This is the slave to Arduino. In the slave to Arduino, I have mapped the camera input and its calculations. Slave 1 Arduino, I have mapped all the magnetometer readings and its calculations. This will direct the vehicle in this correct navigation. I will quickly take you through the simulation part. The headlight is turned on. The light intensity is very low, so the light has turned on. Uh, the ultrasonic sensors are working fine. IMU values are this. This is the LabVIEW input and which will be taken for further evaluation. The motor is on. I will quickly take the sensor values. And the updated values will be shown below. And we could see that it's working. Further, the lab view part will be explained. This is our lab view, front page of our autonomous vehicle, where we have included all the sensors and the speed, automatic and manual modes. I will quickly take you over the automatic mode. I will turn on the simulation. I will vary the left sensor now, so that the distance when the obstacle is near, the warning will be turned on. In similar way for the other front and right sensor. Camera input is changed to the similar value, and the motor speed will be changing. This is the speed string value which we can use in the Tinkercad to move the motor or run the motor. This is the magnetometer reading. We can see the steering values are changed. Now let's switch over the tab to manual mode. Here we can find the automatic mode values will not work now, and only the manual mode will work. Now I will manually steer the car, and the values are shown here. Similarly, the motor speed we can vary manually, and the respective motor string and motor speeds are shown. You can also take the value from Tinkercad. So it's in the 0 position. I will update the value which was taken from the Tinkercad calculations. Now it has changed. So the output which was taken from the sensors are shown correctly over here. So this is the simulation for the front view. Now we will go to the back end. Here we can see the circuit which we have prepared. This is our input stream. From this, the data are taken to the bolt array, and these are further split into 5 values. And these values are uh, went over various calculations, and it is displayed over the sensors, different ultrasonic sensor, light, and which is later which is displayed over the front panel through the displays. This is a front warning and the side warning LED which we have included. When the obstacle is almost near to 30, uh, the side warning will be highlighted. Similar way, this is for the other right sensor, front sensor, and the magnetometer manual mode. Take it to the right side of the page. So we have this automatic and manual mode, which we have seen it in the front view. This is the motor speed and its calculation. This is the steering value when it is in auto mode. We have also included the error part, but while checking this error part, values are not shown in my progress. In the front view, the values are not shown correctly. I will recheck and do this. That's it with the block diagrams. Now we will get into the fuzzy logic. So here, the variable part, we have included the right sensor front and front sensor. Uh, in this variable tab, we have inputted the variables, right sensor, front sensor, magnetometer, left sensor, the camera input. For camera input, we have used 6 membership function. We have used the 6 membership function, which are 3 for left and 3 for right. Similar way, we have a 3 membership function for the magnetometer and all other right ultrasonic sensors. In the output variable, servo steering, we have used 7 membership and rear wheel drive motor. We have used 3 membership: low speed, medium speed, and the high speed. And I have included 30 rules over here in order to run the car correctly. This is our test page. I have placed this in the left sensor and the right sensor, and I will show the map of graph for uh, these values. And for rear wheel drive, I will be using the camera input. So this is the camera input output relationship for camera input, which we have derived. That's it. Now we are in the MATLAB part. This is the code used to process and train the image. Once we run, we will receive an image. These are the trained image received by running the program. This is a training window or graph which shows the accuracy driven while running the program. We could see the accuracy is 98.76, which is good, and we'll test this neural network using this program. I have taken some images of 28 into 28 pixels, and I have added an image over here. So the number we have provided is 3, and it is correctly categorized as 3. Hence, we can finalize the neural network prediction is good. Thank you.